Hello and welcome to Like the Deep. This is Module 1's concept video. Today we are going to debunk the popular myth about LLMs and understand what they do to keep our expectations right. And we are going to look at how LLM understands human language using vector spaces and token IDs. We are going to have a look at hallucination and the different parameters that control the LLM, that is temperature and top P. We are going to look at what context window is and deeply understand it. We are also going to look at what system prompt is and how it is different from the user prompt and understand what it does. And finally, let's have a look at the summary. Let's jump in. Alright, let's get real. Most of you are using ChatGPT or Claude or Gemini every single day, but almost everyone is fundamentally misunderstanding what is happening behind the scenes. When you ask AI a question, you probably imagine there's a high-tech digital libraries. In your head, the AI is printing through a massive infinite library, pulling out dusty filing cabinets, labeled historical facts and reading you the exact entry for whatever you asked. But here's the reality check. That there's no library, there are no drawers, there isn't even a database of facts inside the model. If you could look inside the brain of GPT-4, you wouldn't find a list of presents or a dictionary of definitions. All you would find is trillions of numbers, weights and biases that represent the mathematical relationship between words. We have to stop treating AI like a search engine. Google is a search engine. It finds existing data, but LLM is a generative engine. It calculates new data on the fly. This distinction is the difference between a frustrated user and an AI-powered user today. We are going to look at the exact math of how these models think and why they hallucinate, and how we can use the hidden dials of temperature and top P to master the output. So it's not a librarian, then what is it? I want you to replace that image of a library with a statistical meteorologist. Imagine a weather forecaster who has memorized every single weather pattern on Earth for the last 100 years. They aren't looking at a satellite in real time, instead they are looking at the context, the clues provided by the current day. They see humidity is 92, the wind is shifting west and the barometric pressure is plummeting. Now based on this, they don't know that exactly it's going to rain, but because they have a crystal ball, but they know it's going to rain because their trillion page history book, that specific combination of clues most probably result 85% of the time in rain. Therefore, that is how they are able to predict it. So language models treat words exactly like weather patterns. If you give an AI prompt, you are giving it current clues. If you type the quick brown fox jumps over the dash dash dash, the AI isn't remembering a famous sentence, it is calculating that statistically the word lazy has near 100% probability of following the specific sequence based on everything it read during training. It is not knowing, it is basically predicting or forecasting. Every single word it types is just a high probability guess. But wait, computers don't speak English, but they speak math. Before any calculation happens, the AI has to translate your words into something that it can process. This is where tokens come in. The AI doesn't see the word intelligence as a one unit. It breaks it into chunks, intelli and igents. This splitting is the done to save memory rather than storing entire words. Popular semi-words are assigned as tokens to be efficient on the memory. Each of these chunks are assigned a unique number, and once these words are numbers, the AI predicts one token, just one, and then it takes the token and attaches it to the end of the sequence, and then it does the entire thing again to predict the next one. And this has a fancy name called autoregression or causal. So autoregressive LLMs are a class of LLMs, and this is why AI text streams word by word. It is literally building the sentence in real time, with each new word changing the probability of what comes next. If AI is writing the story, it picks the word suddenly, then the next word probability completely shifts toward action words. This loop continues until AI predicts a special stop token, which tells the system, hey, the pattern is complete, please stop. Now let's get into vector spaces. This is the part that usually blows people's minds. How does AI know that the king is related to the queen but not the refrigerator? It uses something called vector space. Imagine every token is a point on the map. In this space, the distance between the points represents the semantic meaning. The words are used in similar ways. In real world, like coffee and tea, are physically pulled together in this mathematical space. Because these words are not just coordinates, we can do literal algebra with them. If you take the coordinates for king and you subtract the vector of man, and effectively removing maleness from the concept, and then you add the vector of woman, it math automatically pushes you across the map to the new coordinates of queen. This is where AI feels so human. It is not matching strings of text, it is navigating a mathematical representation of human language. It understands that happy is the opposite of sad because they are on opposite poles of specific dimension vector on the map. If when you prompt AI, you are essentially giving it a starting coordinate and asking it to find the most logical path forward through this map of meaning. Now let's have a look at what hallucination is. So if the math is so good, then why does it get things wrong? Remember our meteorologist? What happens if you ask them to predict the weather on a planet they have never studied? They don't have a fact drawer to check, but because the LLM is a prediction engine, it's hard coded to always provide a prediction. It doesn't have a silence mode by default. It doesn't have a proper way of saying I don't know because it is not actually trained to do so. If you ask when did George Washington use his first iPhone, the AI looks at the vector map and sees Washington, historical and 1700s-ish, an iPhone tech 2000s-ish, and since there's no overlapping data, the probability distribution flattens out. But the AI is a pattern completer. So it looks at the style of a question and realizes you are looking for a date. It picks a date that sounds stylistically plausible, maybe 1791, that is to the end of George Washington's life, because that feels vibe and of a historical fact. A hallucination is not a glitch. In the sense that the computer broke, it's the engine doing exactly what it was designed for, predict the most likely next word. Even when it has zero factual basis for that prediction, it prioritizes plausibility over truth. This is where you come in as the pilot. You control how the AI handles these probabilities using two main dials, temperature and top P. Temperature essentially is the chaos dial. When the temperature is low, close to zero, AI becomes a greedy decoder. It looks at the probability chart and says, hey, I don't care of anything else. I'm picking the single most likely word. This makes AI completely factual, but dry and repetitive. It's a librarian. It's what you want for code, math, and medical summaries. But when you turn the temperature high, that is above 1, the AI flattens the chart. Suddenly words that have 5% or 2% chance are given much higher shot of being picked. This is how AI becomes creative. It starts taking risks, picking unusual words, and making poetic leaps. But high temperature can lead to total gibberish. That's why we have top P. Top P is the safety rope. It tells AI, no matter how high the temperature is, only look at the candidates that make up the top 90% of the probability distribution. That is the first 90% of them. If the AI is trying to finish a sentence, the sky is, and the words blue, grey, and clear make up 90% probability, but the word bicycle is the last percent, the top P will physically delete the word bicycle from the list before the AI even gets to choose. It allows for creativity while preventing the model from picking total nonsense. Now we need to talk about AI's biggest limitation, the context window. If the temperature and top P are dials that control the vibe, the context window is the RAM. It is the short-term memory of the model. Think about it. AI doesn't actually know you. It doesn't have long-term brain that remembers your last 3 conversations. Every time you hit send, you're actually sending the entire conversation history back to the model. But there's a physical limit on how many tokens the math can handle at once. This is the context window. Whether it's 8,000 tokens or 1 million, it's a sliding buffer. As your conversation grows, the earliest parts of the chat literally fall off back of the context window. They get deleted from the calculation. This is why AI may forget your name or the instruction you gave it 20 minutes ago. It's not getting tired, it's just that the tokens that have exited the mathematical space. But here's the pro tip. LLMs suffer for something called lost in the middle. They are statistically biased to pay more attention to the very beginning and the very end of the context window. If you bury your most important data in the middle of a massive 50-page document, the attention mechanism might gloss over it. And if you want results, keep your most vital clues at the very end of the prompt or right before the AI starts its prediction. But who is the AI actually listening to? In a professional AI setup, we divide the instruction into 2 categories, the system prompt and the user prompt. Think of the system prompt as a foundation. It is a hidden set of instructions that the user usually doesn't see. It sets the global bias for the entire vector space. When you tell a system prompt you are a world-class Python developer who only speaks in code, you are essentially tiling the entire mathematical map towards technical, logical, and structured tokens. You are telling the AI, ignore the poetic part of your map, live only on the logical part. The user prompt is just a temporary nudge. If you tell a user prompt to be funny, but the system prompt says it's to be professional, you create a vector conflict. Usually the system prompt wins because it's the first thing in the attention mechanism sees and it establishes the persona. This is why jailbreaking is a thing. Users try to give a user prompt that is so strong it forces the AI to ignore the system prompt safety guardrails. As a master prompter, your goal is to use the system prompt to define the rules of physics for the conversation and use this user prompt for the tasks. If you want a specific style, don't ask it for it in every message. Set it for once in system prompt and let the math do the heavy lifting for the rest of the session. Now you saw what was temperature and what is top P and what is system prompt and what is the difference between it and the user prompt, which is the regular query. And now we want to see how to really use them properly. Mastering AI is all about the synergy between these things. If you want a creative partner for writing sci-fi novel, you want higher temperature and higher top P. This lets the AI take creative risk but keeps it within the realm of the coherent language. If you want a rigid assistant for checking your Python code, you want a low temperature and low top P. This forces the AI to be extremely literal and picking only the most standard correct tokens, ignoring everything even slightly experimental. Understanding this balance changes your relationship with the machine. You stop fighting with the AI and for lying and start realize it's just that you had the temperature too high for the factual task and your top P is too low for creative ones. You aren't a prompter anymore, you are a weight tuner. The ultimate power move for professional developers: pin the system prompt. Even as context window slides in the middle of the conversation is forgotten, the system prompt is kept at the very start of every new calculation. It remains the North Star, ensuring that even after 10,000 words, the AI still remembers it's a pirate, coder, or factual librarian. You control the memory, you control the persons, you control the truth. So let's wrap this up. First, we saw that AI is a predictor, it's a weather forecaster for words, not a database of facts. And second, we saw that vectors are key. Meaning is handled through high dimensional math, allowing the AI to understand relationship between concepts. Third is to control matters. Temperature controls the risk, top P controls the quality. Fourth is about hallucination and why it is stylistic. It happens when the prediction engine has to guess without data. Fifth is what is the context window. The first few get lost as the context goes beyond limit and the issue of dropping in the middle exists very well. And sixth, we saw about what is system prompt and how it compares the user prompt and how the system prompt defines the characteristics of the LLM. You now had a better theoretical, technical understanding of LLMs than 99% of the population. But theory is only the half the battle. To truly master these tools, you need to see them break. In our next video, that is the lab, we are going to open up Google AI Studio, the playground. I'm going to show you how to manipulate these settings in it real time. We are going to make the model hallucinate on purpose. We are going to fix it using top P and we are going to find the Goldilocks zone for your specific projects. The engine is warmed up. Now let's go into the lab and see what it can do. Cheers.